Okay, a couple things to look forward to this week is some of these papers were handed out on Friday during class, and that was just a front and a back. And due to what we thought could possibly be some weather coming in and possibly leading to some late starts or cancellations, a second set of papers was handed out later that day. That was a front and a back, a front and a back. So whether you visualize that as 2 or 4 pages, on this one that has some of these abbreviations on here, we want you to put the type of equation that's in the box, it's classifying it, and then the blanks are there to balance it. And we'll go ahead and take a look at, for instance, number 4. Here it looks like we've got some chromium 3 chloride. Okay, this setup really isn't the best, but beggars can't be choosers. Chromium 3 chloride plus. Then I see we've got some potassium phosphate. Okay, so potassium phosphate. And remember, the charges will not change from one side of the equation to the other. And here, remember, this is the reactant side of chromium is +3, chlorine's -1, potassium's +1, and phosphate's -3. So when these go to the reactant side, the charges again do not change. So with what we see here, the positive ion of this compound would bond with the negative ion on this side. Remember what we talked about in class when you're visualizing these markers here, that if these tips were the north pole of that of a bar magnet, they would repel one another because it has to be like charges that would attract or hold the compounds together, or hold the magnets together in this sense. So in that case then, in this we have one compound switching over on the other side, and you see how that's written on there. Okay, so what we see happening then is the chromium is now bonded with the phosphate. Okay, PO4 plus our potassium here bond with the chloride. Okay, so we had 2 distinct compounds that had switched twice. This chromium switched with the potassium to bond with the phosphate over here. The potassium switched with the chromium to bond with the chloride over here. So 2 replacements had taken place. So therefore we know number 4 then is a double replacement reaction. Then the last thing that we see we have to do is balance that then. Okay, so we've got some chromium, we've got some potassium, we've got 1 and 1, and 3, 1. The chloride ion, I see we got 3 on the left, 1 on the right, and then the phosphate ion. We've got 1 on the right and 1 on the left. So as we look at this, looks to me like the best place to start would be that of the potassium, where we got 3 on the left and only 1 on the right. So if we put a 3 here and distribute that through the entire compound, changes that to a 3, then the chloride also to a 3. And therefore we would have that equation balanced then as being 1, 1, 1, and 3. Okay, so a lot of the times these equations maybe look like they're fairly difficult, but once you get better at balancing these, you won't have near as many problems. Again, a lot of practice will certainly help. And also we'll go ahead and take a look at, for instance, number 10, where we see you have to finish that equation. You see we've got some HNO3, and we're reacting that with, should I just look at it, was it potassium? No, magnesium. Okay, so we've got HNO3, HNO3 plus some magnesium. Now, one of the things that we know is it doesn't give you what the charge of magnesium is in this equation. But we know that, again, the charges will not change from one side to the other. Magnesium being in column 2 would be a +2 charge. So an indication that this would be a single replacement reaction is what we said in class, is that we see a lone or single metal all by itself. So in that case, the single replacement of this magnesium will replace the hydrogen and bond with the nitrate, but on this side. So when that happens, we have some magnesium in NO3 plus hydrogen. And again, remember, hydrogen being a gas, okay, don't forget that that is a diatomic molecule, because if you do not put that little number 2 here, these equations just won't balance. Okay, put our charges in, +2 - 1. Again, that doesn't add up to 0, so the least common multiple is 2. And again, the answer that you get when you make this division tells you what to put below. 2 divided by 2 gives you 1. 2 divided by 1 would give you 2, but we got to put that in parentheses then. So we've got Mg left parenthesis NO3, right parenthesis and 2. Now we see the last thing we need to do is balance that equation. Okay, so we've got magnesium and we've got some hydrogen, 1, 1, 1, and 2. Then we've got the nitrate ion. Okay, so we've got 2 on the right and only 1 on the left. Okay, so there's only one place that we can start, and that is with that of the nitrate ion, because there's 2 on the right, 1 on the left. So if we put a 2 here and distribute that through, it balances out our hydrogens and it balances out our nitrates as well. So that will give us coefficients of 2, 1, 1, and 1. Okay, so we had finished the chapter, I do believe, in one of our last presentations that was put online. And again, this paper was handed out to you early in the day on Thursday, and then a second set was handed out then on Thursday as well. And there, that was 4 pages, and we have some vocab terms that will be assigned tomorrow. Looks like we won't have any problems starting on time tomorrow, I would not believe. And whether we have school all 4 days, that remains to be seen. But we will go ahead and take a peek at, let's see here. Perhaps what would look like on the back side of the paper that has your name on it, it says BaCl2 and H3PO4. Okay, so we have some barium chloride, BaCl2 plus some H3PO4, which is phosphoric acid, and it tells you it's a double replacement reaction. So in this case, remember the charges do not change. Barium's in column 2, chlorine's a halogen at -1, so that's why there's 2 of them. Hydrogen's in column 1, so that's +1, so there's 3 of that, +3, and again the phosphate ion has a charge of -3. So in a double replacement reaction, remember the positive ion of this compound will bond with the -1 on the right side. Same thing with this. The barium is the positive charge in this compound, bonds to the negative charge in this compound, but on the right side. So what that would give us then to finish this, okay, we'll start with barium. Okay, bonds to the phosphate, PO4, and then we've got hydrogen and chlorine. The charges do not change, that's +2, that's -3, +1, -1, that adds up to 0, so that one is fine then. So 2 and 3, the least common multiple is 6. 6 divided by 2 gives you 3 here. 6 divided by 3 would give you 2. Okay, so now the last thing to do is balance this. We've got, let's see here, some barium, some hydrogen and chlorine, and then the phosphate ion. Okay, so barium's left is 1, barium's right is 3, hydrogen's left is 3, hydrogen's right is 1, chloride's left is 2, chloride's right is 1, phosphate's left is 1, phosphate's right is 2. Okay, so it looks to me like the best place to start then would be with that of our barium. Okay, we got 3 on the right and 1 on the left. So let's go ahead and put a 3 here, distribute that through the entire compound. That gives us 3 here, 3 times 2, that gives us 6 for the chlorines. Okay, so the next thing we can do is, let's go ahead and balance out our phosphates, or you can look at your hydrogens. We've got 2 to 1, or hydrogens 3 to 1. So what we can do is, let's you could say, since these are odd, both of these are odd, I guess. If we just put a 3 here, that would just give us 3 chlorines over here, so that would not work. So on trial and error would tell us we got 6 chlorines on the left. The only way to get 6 chlorines on the right would be to put a 6 there. That balances out your hydrogens and then also your chlorines. So the last thing to do then is get our hydrogens and phosphates balanced. We got 6 hydrogens on the right. So in order to do that, 6 divided by 3 gives us 2. 2 times 3 gives you 6. And then 2 times 1 for the phosphates gives you 2. That now balances that equation and will give you the coefficients of 3, 2, 1, and 6. Okay, so don't forget those vocab terms. If you haven't started them already, please get started on those. We'll be perhaps having a vocab quiz on either Wednesday or Thursday. The next week plans have been uploaded. We also try to do an activity that we use a chemical reaction to determine and make predictions, and that's why this chapter is so important. So we will pick up with you next time.